After solving part A of this problem, we're going to solve part B. Calculate the mass of sodium carbonate and mass of water in the washing soda crystals. So first of all, we want to calculate the mass of sodium carbonate and the mass of water, and then use these results to find N in the formula. So let's write down the concentration of sodium carbonate we already calculated in part A. It is 0.100 moles per decimeter cubed. So now let us start with part B. We have to find the mass of sodium carbonate. Let's go back and read the given. So 28.6 grams of washing soda crystals were dissolved in pure water. More pure water was added to make the total volume of the solution 1000 centimeter cubed. So we have 28.6 grams of washing soda. I placed them in pure water and then added water till the volume became 1000 centimeter cubed. First, we have to find the mass of sodium carbonate. So, to calculate the mass, we should have the number of moles and the mass of 1 mole. In part A, we found the concentration of sodium carbonate, which is 0.100 moles per decimeter cubed, meaning that 0.1 moles are dissolved in 1 decimeter cubed or 1000 centimeter cubed. So 0.1 is the number of moles of sodium carbonate. So now we figured out the number of moles. What about the mass of 1 mole? A very easy way. As if I'm calculating the relative formula mass, I will calculate the mass of 1 mole of sodium carbonate to obtain 106 grams. I used the relative atomic masses, so now I have the number of moles and the mass of 1 mole, in which I can calculate the mass. It is 0.1, which is the number of moles, multiplied by the mass of 1 mole, which is 106 grams, equals to 10.6 grams. So this is the mass of sodium carbonate in 28.6 grams of washing soda crystals. So in this way, we found the mass of sodium carbonate. Next, we need to find the mass of water. So I have 28.6 grams of crystals. I already calculated that 10.6 grams of these crystals are sodium carbonate. The rest are water, since the 28.6 grams contains sodium carbonate and water. If I know that 10.6 grams of these are sodium carbonate, so the mass left is for water. I subtract the mass of the entire thing by the mass of the sodium carbonate to obtain the mass of water. So, it's 28.6 grams minus 10.6 grams equals 18 grams. So simply we subtract the whole mass by the mass of sodium carbonate to obtain the mass of water. So now I have the mass of water and the mass of sodium carbonate. I have to find N. We have this formula right here. As you can see, N is unknown. So how to find the number of moles of water? The mass of water is already calculated above. It is 18 grams. So I know that the mass of water is 18 grams. If we think properly, we find that the mass of 1 mole of water is 18 grams. How? From the relative atomic masses, 2 plus 16 equals to 18 grams. So if the mass of water is 18 grams, hence the 18 grams are found in 1 mole of water. We previously calculated the mass of moles, but here I have the mass of 1 mole. I know it's 18, so the 18 grams are found in 1 mole of water. So we have 1 mole of water since the mass is 18 grams. 18 is equals to the mass of 1 mole of water. Now let's go back to see the number of moles of sodium carbonate. As you know, it is 0.1 moles. So the number of moles of sodium carbonate equals 0.1 moles. Now I have the number of moles of water and the number of moles of sodium carbonate. The 1 represents 0.1 times 10, meaning to get number 1, I should multiply 0.1 by 10. So the number of moles of water are 10 times more than the number of moles of sodium carbonate. Let's repeat. The mass of 1 mole of water is 18 grams. So this is the mass of 1 mole. So we have 1 mole of water. We said that the number of moles of sodium carbonate is 0.1. If I want to compare between the number of moles, I notice that the number of moles of water is 10 times more the number of moles of sodium carbonate. So I replace N with 10. Why? Since we said that the number of moles of water is 10 times more the number of moles of sodium carbonate. So the formula is sodium carbonate 10 H2O, water. So we have 10 molecules of water.